Today I will finish up my presentation on last week, and then Mr. Jong-Hwan will guide us on discussion for next week and go on to this today's schedule for subship planting. Okay, so I guess I finished around this one to explain about what is concurrent engineering. The key element was to reduce time, because the time is more critical in modern manufacturing compared to the cost and quality. CQT, cost, quality, and time is three most important element for any manufacturing or any business. But I'm saying time is more important than before. So how to reduce the time together to provide new product to the market? You need to have a structural method like as a concurrent engineering. But the problem here is data consistency, data mismatch between phases or domains. Because the procurement and construction should start before previous stages finish, so that there can be a change in design, change in procurement item or procurement provider. We call it the vendor or provider. Different provider or vendor may have a different system. Say, I want to change the provider for pump from Japan to Brazil, then something should change. Same pump, but the provider changed. Then the communication should be changed, right? At least. So anyway, the data consistency is more important. Can be a more problem. So that you need to have a technology like database management. All right. So in old days, there has been a sequential execution. So when it is finished, there is a drawings and bill of material. Bill of material is a component list, or assembly tree. You can say assembly tree, so that we can start procurement. And there is a separate unit, and they should purchase good quality. So here again, they need to have a cost and time and quality altogether. Procurement. At proper time, the part should be arrived to the construction or manufacturing with good quality and good time cost. But they want to start concurrent execution starting before it is ending of designing. So there is a 2 or maybe 3 or 4 separate bill of material, and also separate different drawings. Drawing 2 can be different from drawing 1, comparing to this completed work. This one is finished well, so the quality of design is very complete. But now it is incomplete drawing, incomplete material is coming. So you need to have a data consistency problem. And design change management is also important. In other words, configuration management. Right, so getting the design input early before finishing up So process is for chemical process simulation. This is for gas and oil plants. And then we can arrive at equipment, which pump, which valve, or which compressor, or cooler, boiler, and then we can purchase. This is purchase, because when the company, another company, they should provide their own design and manufacturing and also drawings. And then when it is arrived, you should have the equipment should be installed. So we need to have a foundation drawings, installation drawings. It's complicated. And so something happening, a safety valve case, something is wrong. What is wrong? Number and size and the cost estimate and weight estimate. And also you need to have a support and load estimate. There's something happening. If we skip up to reduce time, something may be well finished up. So engineering or design must be, or calculation, or structural estimation, or support load estimation should be correct at the beginning. So you need to have a more simulation than before. So you need to have a more computer simulation than before. Because it is something is uncertain, changes, more changes. So you need to have a design change management. Is must. So I'm not explaining full details. But anyway, there is a source of changes. So supplier and subcontractors, they need to have a quality and also time of delivery is important. Otherwise, see, there's a conveyor belt is going on to assemble a car. One part is missing. It is not coming. Everything other is okay, but one is missing. Then whole assembly should be stopped. Right? So its timing is very important. On-time delivery is important. Also, quality of component is also important. You may remember a big disaster problem in Toyota case. There was only small spring component around the brake system that has a problem. The whole company has a big problem because of the small spring comes from a very small company. The quality problem. So quality and delivery is very important in this complex system of management. Because it's a project management system, because it's complex, we also say there are so many different domains: engineering manager, procurement manager, site manager, construction site, and also project control is important. So they have a support team only for project management. Big project is ongoing. And this is typical for chemical process plant. So we start from a process design. Process flow diagram is coming from chemical engineers are doing this one. And then they have a material balance between the chemical components. Say you are trying to making a gasoline, but it is coming from oil, crude oil. But there is a different separation coming from crude oil. One portion of them is gasoline, right? There are quality differences between diesel oil, gasoline oil, and other mortar. So you need to have a material balance, including heat balance, and then equipment data sheet, right? So you need to purchase equipment to provide a whole plant. And then this is a kind of drawing. It's a simple 2D design. Piping instrument diagrams. And then operation instruction. This is the process of chemical plant design. And then there is more explanation of each items. You can see, or if you raise a question, I can answer. This is same process or procedure of chemical plant design process, and the same PFD, PNID, and piping instrumentation, equipment specification, procurement and purchasement, vendor drawing. Vendor is a manufacturer of each component or equipment, and then finally you should have a installation. So once again, in different format, process simulation, data sheet, equipment selection, equipment purchase, and vendor, the manufacturer of equipment, and then foundation installation drawing. This is the process. And top side is ocean plant terminology. Ocean plant is simply there is a big barge floating platform, and on top of that big barge, there is a chemical plant is installed on top of a big barge. This is altogether we call ocean plant. So on top of the big barge, we put a chemical plant. We call this is a top side. Top of the barge, top side. Bottom side, top side. And there is a process, similar process. Design basis is a design requirement, process simulation, PFD, and PNID, and the other